What do we do first? Y equals x squared over the square root of x plus 4x over the square root of x plus 3 over the square root of x. So what does that equal? That equals x to the 3 halves plus 4 over x to the 1 half plus 3x to the negative a half. So what's the derivative going to be? X to the half plus 2x to the negative a half plus, or excuse me, minus 3 over 2 x to the negative 3 over 2. All done. Simplify first. Simplify. 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 I haven't given you any tools yet other than this like one basic rule. So if you see something that you don't recognize, you need to push it into something you do recognize. So simplify, simplify, simplify. Right. So if you do y prime, what's the derivative of a e to the v? A e to the v. It's a e to the v. The derivative of e to the v is what? E to the v. Yes, the coefficient is just along for the ride. It just sits there, does nothing. What's the derivative of e to the x? They're just changing and calling it v. They were kind of ambiguous here, and they didn't say specifically that it's v, and they added in like b and c and a. But the only one that makes reasonable sense is for the variable to be v. So that's going to be plus, that's bv to the negative 1, right? So what's the derivative of bv to the negative 1? Negative b, v to the what? Negative 2. And then this is cv to the negative 2, so that's going to be minus 2cv to the negative 3. Done. That's it. That's it. Is equal to negative 10a y to the what? Negative 11 plus what? Done.
Oh, come on.
Kazing!
Just do all this again. Yeah, I did it all.
6x squared, yep, plus
6x
minus
12, 12.
Done, yes. Is that nicely factorable? Yeah, because you factor out a 6 and you get x squared plus 6 minus x squared plus x, sorry, plus x minus 2. Does that factor?
Yeah.
Y prime is equal to 6 times x, what? Plus 2 times x minus 1. What does x? Okay, so we want where the derivative is equal to? Horizontal tangent line. So when does this equal 0? When x is equal to what? And 1. Find the points. Are those points? No, those are x values. To find points, what do you need to do? So what is f of 1 going to be? That's going to be 2 plus 3 minus 12 plus 1. That's 5 minus 12 plus 1. So 5 minus 12 is negative 7. Negative 7 plus 1 is negative 6. So the first point is 1 comma negative 6. How do you find the second one? You plug in what? F of negative 2. The original function. The original function. On the points on the curve. Can the derivative and a function intersect? Sure, they can. E to the x intersects with its entire derivative because the derivative of e to the x is e to the x. So 1/6. So then we plug in negative 2. We get what? You get negative 16. We're plugging in negative 2 into the original function. Plus what? 12 plus 24 plus 1, right? So that's going to be negative 4 plus 25 is 21. So the other point is what? 2 comma 21. Done. That's it. That's it. That's it. What does horizontal mean? It means rate of change is 0. If at any point in your life you get stuck, take the derivative and set it equal to 0 and solve. It is by far the most common thing you'll do in calculus. Is studying when rates of change is 0 are really, really, really common. Rates of change is 0 is when something turns around. It's when something gets to a maximum, when something gets to a minimum. Are maximization and minimum problems pretty important across like all sciences? Absolutely. Absolutely, absolutely. Go to lunch. So what's the derivative of x squared? We know that already. It is 2x. What's the derivative of g? 1. In this case, because g is x, the derivative is 1. That's correct, right? What is f of x times g of x? What's that going to equal? X cubed, okay. What is f prime of x times g prime of x? 2x. If this right here is a new function, we'll call it h of x. Can someone tell me what h prime of x is equal to?
3x squared.
3x squared. Can you tell me what statement you can now make? We just showed that f of x times g of x is x cubed, and the derivative of that is 3x squared. The derivative of f times the derivative of g is 2x. Are these the same?
No.
Not the same. So what does this mean? It means that if you have two functions multiplied together and you take the derivative, what does it not equal? Big time not equal.
The original functions.
F prime times g prime. It does not, it does not, it does not, it does not. Say it with me on 3. 1, 2, 3. It does not. This is a terrible, awful, awful mistake to make. Do not make this mistake. Do not make this mistake. Do not make this mistake. So again, I'm not going to go through these steps right here. They will be in the notes that are, I'll put these up. But this thing is in your book already. This is huge quotient. It simplifies, it simplifies, it simplifies. What this means is, the really important thing is right here. This is called the product rule. We learned the power rule before. This is called the product rule. This is important. Product rule. Super important. So if you're taking the derivative of the product of two things, this is what you take. So if you're doing the derivative of f times g, it's f times the derivative of g plus g times the derivative of f. Is this pretty easy to remember? Yes. If you're taking the derivative of the product of two things, it is the derivative of f, sorry, it's f g prime plus g f prime. Can you write them in either order? Yeah. A plus b is the same as b plus a. So it's f times the derivative of g plus g times the derivative of f. That's it. No.
1, -1.
Negative 1 plus, what's the derivative of the square root of t? Can someone tell me? 1/2 t to the negative 1/2 times 1 minus t. There's your derivative right there. There it is. That's it. There's no more to it. Can you simplify that a little bit? Sure. What's that going to be? Negative root t plus 1 minus t over 2 times the square root of t. That's one way to write it. Now, what's another way we could have done this one? Let's say I'll write it again. F of t is equal to the square root of t times 1 minus t. If I didn't tell you this product rule, what would you have to do first? What would you have to do first? Yeah, distribute it. You'd end up with root t minus t to the what power? 3 halves. Because this is t to the first, and square root is 1. So can you do the derivative there? Absolutely. F prime of t is going to be equal to 1/2 t to the what? Negative 1/2 minus 3 halves t to the what? To the 1/2.
This one wasn't the homework.
It was. It was. Now, theoretically, should these be the exact same?
Yes.
Yeah. Can we simplify these to be equal to each other? Absolutely. We absolutely can. So are multiple methods going to work sometimes? Absolutely. In some cases, is the product rule going to be much easier to do than multiplying it out? Absolutely. For example, well, I can't do that example yet. I'm going to do the third one first. G of x times what? G of x times, and we'll write the d dx of this. We'll do an extra step here. Plus g prime of x times the square root of x, right? What's the derivative of the square root of x? What was it? 1/2 x to the what? Negative 1/2 plus g prime of x root x, correct? So that's f prime of x. This thing is asking for f prime of 4, right?
Yeah.
So what do we plug in for x? 4. So we do f prime of 4 and end up with g of 4 times 1/2 4 to the what? Negative 1/2. I'm just plugging it in so we can see this plus g prime of 4 times root x. What's g of 4?
G prime of 4.
No, g of 4.
Oh,
2. So this equals 2 times 1/2. What is 4 to the negative 1/2? It's 1 over the square root of 4, which is what?
1/2.
1/2 plus what's g prime of 4?
3.
3. And what's the square root of 4? So this equals 2 times 1/4 plus 6. So what's the answer going to be?
6.5.
6.5. 13 over 2. Done. There's an example of how the product rule can be used. They can specify it any way they want. This is the product rule. This is another bread and butter. You're going to do the product rule literally hundreds, if not thousands of times this semester. Hundreds, if not thousands of times. Let's do more examples. In order to find the slope of the tangent line, we need to find the derivative. Exactly. Here is the function we need to find the derivative of. So y prime is going to equal, what's the low function? Low d high, which is, e to the x, minus high d low. What's the derivative of the bottom going to be? 2x. And what's it over?
Low square.
1 plus x squared squared. So it says find an equation of the tangent line to the curve at that point. So if we want to find the slope at that point, what x value do we have to plug in? 1. There it is. The 1 is right there. So we want y prime at what value? 1. So we plug in 1, and what do we get? We get 1 plus 1 times e minus e times 2 all over what? 2 squared. What's that going to equal? That's 2e minus 2e all over. What's that equal? 0. It's 0. So what's the slope of the line? 0. What kind of line is it therefore? So what's the equation of the line, kids? Y equals what?
1.
No.
No,
E over 2. Look what the thing tells you. It tells you that at 1, what's the y value? E over 2. It's a horizontal line. It's a horizontal line through that point. If you said y equals 1, is that correct? No, it's not. If you said x equals 1, is that correct? No. That would be a vertical line. You want a horizontal line through that point. What is the value? What is the output value at that point? It is e over 2. Absolutely. What was the thing that made this question possible? The quotient rule. If you have the quotient rule, you can find the slope really, really easily.